we had seen the resistivity and its relation with temperature, and we got that rho T is equal to rho naught 1 plus alpha and delta of T. As we know that R equal to, now what about resistance? Resistance is given by rho L over area. So if resistance follows this relation, as R is directly proportional to rho, if L and A are constant, then resistance at that particular temperature becomes R naught 1 plus alpha delta T. Okay, this is a very important relation. We shall do some numericals exactly on this formula, and again we get alpha is equal to R at certain temperature, R at reference temperature over R naught into delta T, or RT minus R naught into T minus T0. Okay. Now for copper, let's analyze some graphs. For copper, this is temperature and this is resistivity. For copper, the graph is little more non-linear and becomes like this. So this is a pure metal and conductivity increases little like this. Okay, in case of nichrome, this is for copper. Again, the graph is plotted between the same two parameters. In case of nichrome is what? It's a very high resistance alloy which is used in case of heating elements. So it has a linear variation in its resistivity with a rise in temperature. Okay, because we are only dealing with NCERT topics, so we cannot go more deeper into that relation, you know. So this is about pure metal, this is alloy. At last we have the graph for what? Semiconductors. So in case of semiconductors are those substances in which the charge carriers are what? Electrons and holes. And this is very important relation in case of semiconductors, that when the temperature rises, the number of charge carriers, that is N, increases exponentially. Means there are so many covalent bonds are broken and we get large number of electrons and holes. So if N increases, according to that relation, rho is equal to m Na square tau. So rho is inversely proportional to number density. So when the temperature rises at high temperature, what happens? N, number of charge carriers, increases. So this results into decrease of the resistivity. Mind it. At rise of temperature, the number of charge carriers increases and the resistivity decreases. That is, the substance becomes more and more conductive, or its conductivity increases. That's it. So conductivity sigma is directly, or sigma equals to 1 over rho. So rho decreases, then sigma increases. Okay, now what about the graph? This is temperature T and that is resistivity, and this falls exponentially. So this is a this is for semiconductor and this falls exponentially. with the rise of temperature. That we say when the temperature increases, the resistivity decreases or the conductivity increases. So, and they have got a very special property that at absolute zero, the resistivity is enormously high. You know that the conductivity is formed by the free charge carriers. So at absolute zero, as we go down to the axis, then we get absolute zero, and that particular temperature the resistivity becomes enormously large. There is no free charge carriers available, and making the semiconductor a pure and perfect insulator. Okay, thank you. This is for today's idea. Note this down.